Hi, today we are going to show you how the key components in a speaker come together to generate the pleasant sound you are accustomed to hearing on an everyday basis.
Here, we will show you how a speaker works. Speakers have three main parts: a coil, called the voice coil, usually made of copper or aluminum, attached to a driver, also called the cone, and a round magnet, which is actually more like in the shape of a donut. The driver is conical in shape and is attached to the voice coil, which is wrapped around a cylindrical piece of metal that sits in the gap of the magnet. This is the part of the speaker that acts as the electromagnet. The point of a speaker is to turn electrical energy into acoustic energy. But before I explain the process, here is some information about how an electromagnet works.
Here we have a drawing of an electromagnet. The basic components are a battery and coil. The current is going to flow from the positive end of the battery through the coils and then into the negative end of the battery. An electromagnet is essentially a magnet created by current. Using the right-hand rule, we can determine the direction of the magnetic field generated by the current. So, in order to simplify the right-hand rule, we're just going to take the right-hand rule at the top and at the bottom of the coil. So at the bottom of the coil, the current is going this way, so the magnetic field is going to be going in the directions of the fingers. In the top of the coil, the current is going into the page, therefore the electric field that is generated is going to go in the direction of the fingers, like this. If you sum up these forces, you get a net magnetic field going like this. And then in the bottom, it will go like this, making the south end here and the north end here. In order to make the electromagnet more powerful, you can either increase the current or increase the number of coils.
The driver is what creates the sound as it moves back and forth, and the movement is caused by a change in direction of the current applied to the electromagnet. By changing direction, you change the north and south poles of the electromagnet, causing it to attract or repel the permanent magnet. Of course, different speakers have different capabilities, and these capabilities may vary due to any of various factors. For example, the faster the driver moves, the higher the frequency it will produce. Encased speakers will be able to produce louder sounds than naked speakers, due to the fact that an enclosed space keeps the entire speaker from vibrating, making the losses in vibration minimal and optimizing sound, particularly low-frequency sounds.
The Big Jam Box by Jawbone has a range of 90 Hz to about 20 kHz, meaning it vibrates from 90 to 20,000 times per second. Using our kilowatt, we determined that it uses an average of 30.9 watts. Assuming it is used 300 hours a year, it gives us 9 watt-hours per year. This device has two high-frequency speakers, one on each side, one here and one here, and then one low-frequency speaker in the middle.